Hello everyone. In this video we will cover the matrix product, inverse of a matrix and eigen system of a matrix. So let's start. First of all, matrix product. Consider we have two matrix A which has order 2 cross 3 2 by 3 and another matrix is B which has order 3 by 2 and its product is non-commutative in nature. So let's prove it. So first we perform the uh, matrix product AB. So let's start. First we take the matrix A and matrix B and we calculate its product. So this is takes place such that we take the column of row of this matrix A and multiply it with the corresponding elements of column of B matrix, and similarly take this row and multiply with corresponding elements of second column, and similarly we take the second row of this matrix and multiply the corresponding elements of first column, and then row of this matrix and multiply with corresponding elements of this column. Thus we get the final resultant of the multiplication of these two matrix, which has order 2 cross 2, which comes from this 2 cross 3 3 cross 2 and 3 are cancelled, and final order is 2 and 2 by 2. Multiplication such that a11 multiply b1 plus a12 21 plus a13 b31, and similarly a11 multiply with b12 plus a12 multiply by b2 plus a13 multiply by b3, and similarly we get the corresponding elements of this, and we can see that the final order of this matrix is 2 by 2. But in case of b by a, its element, because this comes in front 3 cross 2 and this comes at the right hand side, and then 2 and 2 cancels, and final order is 3 cross 3, and the multiplication is also performed similar way as performed in above. First take this row, multiply with the column, this row, this column, this row, this column, and similarly this row, this column, this row, this column, this row, this column, and this, thus we get the final resultant matrix. After that, the calculation of inverse of a matrix. Inverse of a matrix is the matrix or which multiply with the original matrix gives us the identity matrix, and if it is exist, if and only if the rank of the given matrix is equal to the order of that matrix. And the steps to compute the inverse of a matrix is that first ensure that the determinant of given matrix is non-zero in nature, then computes the minors which is equal to the determinant of n minus 1 cross n minus 1 order, which is the sum matrix which is obtained by the elements whose minor we want to determine by eliminating the row and column which contain that elements. Then calculate the compose the cofactor matrix which is equal to the minus 1 I plus j. I means row, location of that matrix in row, and j represents the location of that element in column. Multiply with the minus, and then determine the adjoint which is equal to the transpose of this cofactor matrix, and then we finally calculate the inverse of that matrix which is equal to adjoint A divided by determinant A. There is always keep in mind that determinant of that matrix is always equal to non-zero. If it is equal to 0, then inverse of that matrix never exists. Then eigenvalue. For a matrix A has order n cross n belongs to space n cross n by n, there is n complex eigenvalues lambda which is associated with the n eigenvector which has belongs to the space C n, such that A matrix multiply with the vector x is equal to lambda x, where x represent the eigenvector and lambda represent the eigenvalues and A represent the original matrix. And steps is the compute this equation, and then determinant calculate the determinant of this matrix A minus lambda in, and we get the if we get a polynomial equation in terms of lambda, and by solving these polynomials we get the roots, which is the eigenvalues, that is lambda of our given matrix A, and then put these lambda values in this equation and this equation, and we get the corresponding eigenvectors of that matrix.